Hello class, in this video I'll be doing examples 7, 8, and 9 in section 8.1, inverse trigonometric functions, and we will focus on tangent. The first statement reads, if tangent theta is equal to y, then the inverse tangent of y is equal to theta. And there is another way you can write inverse tangent of y. You can write it as arc tan of y is equal to theta. So if you see arctan y or inverse tangent of y, they mean exactly the same thing. The second statement reads, if inverse tangent of y is equal to theta, then tangent of theta is equal to y. And that is the statement we're going to use to answer questions 7, 8, and 9. And there are restrictions. Y can be any real number. And theta needs to be between negative pi halves and pi halves. And the reason for that is because tangent is not normally a one-to-one function. So if the domain is restricted to negative pi halves to pi halves, tangent becomes a one-to-one function and will then have an inverse. So let's try example number 7. It says determine the exact value of the inverse tangent of negative 1 divided by the square root of 3. And I'm going to start by writing out the sentence. If inverse tangent of negative 1 divided by the square root of 3 is equal to theta, then tangent of theta has to equal negative 1 divided by the square root of 3. And if you look at the unit circle, you'll find two angles that work. Theta is equal to 5 pi sixths, and theta is equal to 11 pi sixths. However, neither of these two angles are in the desired interval. So what we need to do is we need to find the negative coterminal angles for each. So the negative coterminal for 5 pi sixths is negative 7 pi sixths. And this angle is not in the interval negative pi halves to pi halves. So we're going to find the negative coterminal angle for 11 pi sixths. So the negative coterminal angle for 11 pi sixths is negative pi sixths. And negative pi sixths is in the interval negative pi halves to pi halves. So the inverse tangent of negative 1 divided by the square root of 3 is equal to negative pi divided by 6. Example 8. Determine the exact value of inverse tangent of 1. So just like the previous two problems, or previous problem, number 7, if the inverse tangent of 1 is equal to theta, then tangent of theta is equal to 1. And from the unit circle, you'll find two angles. Theta is equal to pi fourths, and theta is equal to 3 pi fourths. And only one of those angles is in the desired interval, negative pi halves to pi halves. And that is pi fourths. 3 pi fourths is too large. Therefore, the inverse tangent of 1 is equal to pi fourths. Okay. Number 9, determine the approximate value of inverse tangent of -4. Now notice the verbiage change here. The previous problem was exact, and we got an exact value. This problem is asking for an approximate value for the inverse tangent of -4. So what I'm going to do is I'm still going to write out the sentence. If the inverse tangent of -4 is equal to theta, then tangent of theta is equal to -4. And for this problem, we're going to have to use Decimus. So I'm going to switch over to Decimus real quick. And we're going to type in inverse tangent of -4. And we want to make sure that in the top right-hand corner, you're in radian mode. And so far we are. So come on over here to functions. And you'll find in the trig section, there is a inverse tan button. Type in -4. And there is your approximate answer. A radian measure of -1.326. So theta is approximately -1.326 radians.